All right, let's pull back the curtain on an industry that is, without a doubt, one of the most important on the entire planet, yet almost nobody talks about it. It's the hidden engine that powers literally everything digital in our lives. This is the inside story of the semiconductor equipment industry.
So let me ask you a question. When you think about all the tech you use every day, your phone, your computer, the cloud, all this new AI stuff, what comes to mind? You're probably thinking about the chips, right? Or maybe the big household names that design them. But what about the companies that build the actual tools to make those chips?
And just to give you a sense of the scale we're dealing with, look at this number, $1 trillion. That's what the semiconductor market itself is expected to be worth by 2030. It's just a staggering figure.
But you know, that trillion-dollar number isn't even the most important part. The real story is the momentum behind it. The market is projected to grow at a massive 9% compound annual rate. Think about that. This relentless, insatiable demand for more and more chips, well, it creates a huge opportunity for the companies we're talking about today, the ones who build the factories of the future.
So here's how we're going to break it all down. First, we'll look at the sheer scale of this market. Then, we're going to meet the architects of the impossible, the companies building these incredible tools. We'll dive into how AI is basically pouring gasoline on this fire, then unpack the high-stakes geopolitical game being played, and finally, look at what the future holds.
All right, first up, the trillion-dollar foundation. Let's really get our heads around just how big and how fundamental this industry is.
So, what is this stuff really? Well, semiconductor manufacturing equipment is basically a collection of the most complex, most precise, most mind-bogglingly advanced machines that human beings have ever built. These are the tools that construct microchips, literally layer by atomic layer. They're building the brains of our entire modern world.
And this is the bottom line, right here. Without these machines, nothing else happens. No smartphones, no internet, no data centers, no AI, no modern cars, none of it. Everything, and I mean everything, in our digital lives starts right here with this equipment.
So who are these master builders? Let's meet the architects of the impossible. It's a surprisingly small club of companies that basically hold the keys to the entire digital kingdom.
You know, making a chip is an incredibly complex dance with many steps, and different companies are the masters of each step. It starts with lithography. This is where a company called ASML, which has a total monopoly, uses extreme light to print these impossibly tiny circuit patterns. Next up is etch, where a company like Lam Research comes in and basically carves those patterns into the silicon. And then you have deposition, where a firm like Applied Materials applies all the ultra-thin layers of special materials that make the circuits actually work.
To make that a little simpler, just think of it like microscopic construction. ASML creates the incredibly detailed blueprint or stencil, Lam Research is the master sculptor with the world's most precise chisels, and Applied Materials, they provide all the high-tech building materials, the advanced inks and concrete to actually build the thing.
Okay, let's shift gears and talk about the single biggest thing pushing this industry into overdrive right now, and that is, of course, the AI revolution.
The demand for chips has always been growing, right? But AI is a total game changer. Why? Because AI doesn't just need a few more chips, it needs a fundamentally different scale of computing power, all housed in these massive data centers. This is causing a huge shift in demand away from just consumer gadgets and towards the industrial backbone of artificial intelligence. And this chart right here, wow, it just lays it all out. Look at the difference. A regular old server sees about 4% growth. An AI server used for inference, that's when an AI is actually being used, sees 18% growth. But an AI training server, the kind that's used to build these giant new models, a staggering 25% growth. That's not a trend, that's a tidal wave of demand for the most advanced chips, which means a tidal wave of demand for the machines that make them.
But as you can imagine, with this much opportunity and this much power, there's also a massive amount of risk. So let's talk about the high-stakes geopolitical game that's become the industry's biggest headache.
And hey, don't just take my word for it. This is a direct quote from the annual report of Applied Materials. They explicitly list global trade issues and export regulations as a major risk to their business. When a company at the heart of it all says that so directly, you know it's a huge deal. And it's not just them. It's the same story over at Lam Research. They say almost the exact same thing. These issues may inhibit our ability to sell our products. This makes it crystal clear that the entire industry is stuck navigating these really treacherous waters.
The tools that connect the world are now at the very center of what's dividing it.
So here's the core problem for them. These are global companies. They have to sell to everyone, everywhere, just to fund the insane cost of research and development. But at the exact same time, they're being forced to navigate this incredibly complex maze of national security rules and export bans from different governments. It's a nearly impossible balancing act.
So all of this brings us to the future of chip making. And really, you can boil it all down to a massive collision between two forces: incredible opportunity and unprecedented risk.
On one hand, you have the opportunity, an AI-driven supercycle that is creating historic, maybe once-in-a-generation demand for more powerful chips. That's the engine. But on the other hand, you have the risk, a world that's fracturing along geopolitical lines, where the very technology to build those chips is being used as a weapon, restricting access and maybe even slowing down progress for everyone.
And that really leaves us with the one final massive question. We've all heard that chips are the new oil, right? The most critical resource of the 21st century. But the real power, the ultimate power, might not be with who has the chips, but with the tiny handful of companies who can build the impossible machines that create them. So the question we have to ask is, who's going to control the tools?